This is a presentation that I did at the George Washington University in March 2024. And the title is I'm Excited to be a Software Engineer in 2024. I want to start by talking about cloud, which was the most disruptive technology of the last 15 years. And I think that'll set a good baseline for talking about GenAI, which has the potential to be the new disruptor, a technology that might surpass cloud in its disruptive effects in the tech industry. And then I want to talk about anxiety, which is really the forever disruptor. And when I gave this talk, it was the day after Sora was released, which was really incredible demo, incredible technology, but also incredibly anxiety inducing for anybody in the film industry, the tech industry. And then soon after this presentation, Devon AI was released. And so I've been like dealing with the shockwaves of these anxiety inducing events ever since GPT 3.5 came out. And I've written a little bit about this, and I'd really like to take some time and talk about it because I think it's an under discussed topic in our field. So if you're feeling anxious about AI in general, I would highly recommend you jump to the third half or the final third of this talk, where I'll address those topics in detail. So about me, I'm a physicist turned software developer. In the last 9 years, I've been a software developer in several industries, finance, logistics. Now I'm in government consulting. My background is a typical tech stack, Java, Python, cloud and DevOps. More recently, I've been working a little bit in AI. I've blogged a lot about AI, and I'm particularly interested in the disruptive effect it's going to have in our industry. And a lot of this came from a place of anxiety originally. Am I going to lose my job? What's the landscape going to look like in 5 years? I've been interviewed by Business Insider on the topic. I've been on podcasts. So generally have some interesting opinions, I would say, but I'm by no means an expert. I'm not an AI researcher. I'm not a professor or a guru. My goal here is just to explore some of these interesting trends in our industry and maybe hopefully help you come away with some hopefully optimistic thoughts about your career and AI's effect on it in the future. So before we talk about the current disruptor, Gen AI, I want to talk about the last 15 years of cloud and help contextualize sort of how a disruptive framework manifests, like over several years in our industry. So I'm going to break cloud evolution into three eras. The first era I'm calling the bare metal era, which really started in 2006 with Amazon Web Services. For the most part in this era, you were just leasing compute, virtual machines, EC2 instances. There were some other cloud offerings like cloud storage through S3 buckets was available in these early days. There was nothing like there is today with hundreds of offerings and multiple cloud providers. Google App Engine did exist in this time, but it was very much a precursor to what Google Cloud is today. And to give it credit, it was a really sophisticated platform as a service that was maybe ahead of its time. The major players in the space was mostly just AWS, but Azure and Google Cloud came into their own in this era. And in my opinion, Dropbox was like the defining early cloud app of this era. I mean, when I used Dropbox for the first time, it was amazing. I still think it's an amazing tool. And it really was a tool that couldn't exist without cloud storage. It's just like a really great distributed computing technology of the time. I'm going to call the next era the microservices era. So starting in 2014 to 2018 or so, we just saw an explosion in managed services. So everything sort of went into the cloud. Before this era, if you wanted to manage a database or set up a content distribution network, it took a lot of I would say operational complexity. And then all of a sudden there were just offerings. So if you're already on AWS, you can just fire up a database. And this was kind of an amazing change. This era also is like characterized by what I'm going to call the container wars. So developers started to write applications that can be containerized and then orchestrating these containers using technologies like Kubernetes, but technologies before it like Swarm and Mesos and Nomad. There was this really interesting competition happening at this time. And this era is kind of defined by how it lowered the barrier to scale. So, creating an app that could scale to thousands or millions of concurrent users became much more tractable in this era. And I would say the defining app for me in this era is Netflix. So Netflix really came into its own in this era. At one point, it was using something like 30% of the internet traffic's bandwidth every night. And it only achieved that scale by going all in on these cloud services, particularly in AWS. Finally, I think the era we're in today is the cloud native era. And, and I mean to point out that the cloud era is not over by any means. So we're still actively in this. I think in this era, you sort of just start with cloud technologies. Everything you build is managed services and platform as a services. We're not really starting by leasing servers like we were back in the day. And I'm kind of feeling like this era is defined by sort of just an emphasis on quality. So you can really stand up an application over a weekend that could scale to a million concurrent users. It was possible in the microservices era, but now it's just I could do it myself as an individual developer instead of a team of 8 developers. So some of the defining technologies in this era, I would say something like TikTok or Argo CD or Zapier, all these technologies that really just they push the envelope on what's possible, and the user experience, it's just expected that they work on mobile, that they're never down, that they're never slow. All these high expectations of high quality for users is kind of like the state that we're in now. So as the cloud evolved, so did technology roles. And I would characterize these in 3 categories. So some roles were characterized by a reduction, some by a transformation, and some by pure growth. And I think it's useful to go through this because it'll sort of set the stage for making similar predictions for how Gen AI is going to change technology roles over the next several years. So roles that were characterized by reduction, I would say like database administrators, on-premise operators, people that were in your server room, people that were like my college once in undergrad, nobody could access their homework for a weekend because there was a disk failure in the server room on campus. So the person that fixed that, there's probably less of those specialists these days, and the ones that are around are probably working in server rooms that giant server rooms that are owned by cloud providers. Roles that are characterized by transformation, for example, software engineering, like I showed, has been changing and continues to change every year. Um, Cybersecurity is another field that's always going to be changing to keep up with current technology. I even have network engineering on here because there's a lot of networking that has to happen to set up a really sophisticated cloud application. Managing, access and availability of the cloud across an enterprise takes a lot of networking prowess. Then there's roles that I think are characterized by pure growth. So the rise of the DevSecOps role, data science and machine learning has exploded in the last several years. Even things like configuration as code, infrastructure as code, CI/CD pipelines, these are now like core tools that maybe weren't even considered in 2006. So I'm going to characterize all of these fields by pure growth. There's a really interesting tool on Stack Overflow where you can look at the popularity of a tag over time. And I think it's fun to do this because it does reflect some of these trends. So like, for example, if you look at sort of different technologies, like for example, database design in blue, you can see that that's clearly tapered off and was more or less dead by 2015, sort of reflecting what I'm talking about with DBA rules. And similarly, a technology like Terraform, which didn't really exist until 2016, is growing and growing and growing, which is an infrastructure as code tool. So I think it's fun to kind of look at some of these trends. I'm not going to go into depth on them. The growth of Python was an interesting one. Another interesting one to me was the growth of Rust. I had thought Rust might be more popular than Python at this time by how often I hear about it. But as you can see, Overall, it still has a lot of growth to go, but it is trending upwards. And you can't really see this slide because my head's in the way, but also I was just showing that container orchestration technologies kind of reflect these trends that I've been talking about. So just because cloud is a mature technology doesn't mean it's not still growing. In fact, the cloud computing market continues to grow year over year. In 2022, it was estimated to be valued, and I don't know exactly how, but you're talking about a market share of almost $500 billion. Here's a plot from Grandview Research kind of showing the growth over time, and I don't know how accurate this forecasting is, but you could see that like if it grows sort of linearly, you know, we're talking, close to $1 trillion a year in the near future. The major players are also continuing to shift. So for a long time, and probably still today, Amazon is the major player in cloud. But Microsoft is really trending up here. And I think, which I'll talk about later, I think the Gen AI is going to push Microsoft past Amazon and really into the stratosphere as like the de facto cloud for organizations. It's also important to realize that cloud hasn't really permeated all industries the same. So an industry like media, it's very much cloud heavy. But when you look at industries like banking and government, healthcare, they're still very much not making use of cloud technology. So there's lots of money to be made due to the inefficiencies of these, sectors, these industries. And so for years to come, there's going to be a lot of migration of these old technologies onto the cloud. And in the same way, I'll talk about this later, I think Gen AI is also going to follow these trends, regardless of how fast the technology moves. Also, the cloud is still penetrating the third world. And I kind of point all this out to just show that there's still plenty of jobs in cloud growth, even though it's a mature technology at this point. Okay, so enough about cloud. Let's start talking about Gen AI, which is the new disruptor, the new emerging technology of our day. So, like many of you, my first reaction and my continual reaction to all this is like, holy crap, this is crazy. This seems like magic. There's so much interesting stuff going on in Gen AI. And I made this slide 2 months ago, and it's already laughably out of date. So I'm not even showing anything from Sora, which is like the incredible video creation technology. But even from this old slide from a couple months ago, there were so many interesting things going on, live animation of images, and this female isn't even real. This was an AI generated image, and then an AI animated motion capture on top of that. The ability to solve math equations, the ability for GPT-4 to look at this comic strip and tell me why it's funny, to understand these relationships, like this is a therapist and this is a patient, and they have a game on their head and there's a pun in here. Just this like deep, human like understanding of it's just crazy. I don't even have to belabor this. I think you're all in agreement with me here, right? So in anticipation of this talk, I really wanted to understand like what's different about Gen AI. I mean, AI has been on the docket for 30 years. So like why is this so different? What happened? Was there some new technology or some breakthrough, or is this just a buildup of lots of little innovations? I really didn't understand. So I asked ChatGPT, gave me a good answer, but it didn't really tell me much. So I'm going to take a little side quest here and try to just help you understand, or help myself understand, sort of like what are the key innovations that led us here. And feel free to skip these next few slides. All right, so I'm going to try to just give you a very high level layman's overview of kind of what I think is important for understanding what the big breakthrough has been for where we are now. At first, you have to understand like that most AI models these days are neural networks. And what a neural network is, it's you start with something like an image or text or a sound wave, and you're passing it through a network of transformations. And ultimately, the goal is to identify something in the image. So maybe if I passed this picture in, what I want in the output layer is a list of objects in the image. So maybe the output of this would be Audi A7, road, trees. So that's the goal. And what happens along the way is like very sophisticated, and I know very little about it. But what I do know about it is what the network sees is it sees representations of the image at different scales. And this happens in these different layers. So maybe in one layer, there's very fine-grained details that are being noticed by the model. Maybe it's like breaking this image into a series of edges and corners and little like pixel level details that our eyes aren't really picking up on, but our brain is probably doing the same thing. Then in another layer, it's looking at more coarse grain features, wheels, hubcaps, headlights, curves. Then maybe at an even more coarse grain level, it's seeing things like doors and windows and bumpers. So if you pass enough pictures of the cars into these networks, it's called training. You pass in 1 million pictures of cars and you tell it, this car is an Audi, this car is a BMW, this car is a Ford F-150, and it sort of represents the car at all of these different uh, levels of detail. And ultimately, through some miracle of AI engineering, once it's seen enough cars, then it can begin to predict. So you start passing it pictures that it hasn't seen before, and it'll say with 97% confidence, like, oh, that's an Audi A7. So ultimately, that's how most AI models work. They're these neural networks. They're trained on lots of data, and they are trying to extract meaning and objects and things from text or images and whatnot. So, okay, what's different now? What is Gen AI? So there's obviously different variables. I mean, you could have like lots of nodes or lots of layers or what is the big difference? Well, the big difference is the logic that's occurring inside each of these nodes. So the way these nodes work, you have information called input coming in, and then there's a transformation function in here that produces output. So the actual function that's embedded in these nodes is really the key breakthrough that occurred in 2017 with what's called the transformer architecture. So if you look back into like early neural networks, one of the early popular ones was called a recurrent neural network. And without getting into much detail, because I don't know shit about it, like if you look at this diagram, the hyperbolic tangent function was maybe a key function in this transformation between input and output. But as the technology evolved, researchers got more sophisticated with the actual like brains inside of these nodes. So you had long short-term memory architecture and gated recurrent units. And as you see, people explored more sophisticated transformation functions in the nodes. And as they did that, the networks had certain emergent properties like better memory or other properties of the network that were advantageous over the recurrent neural net. Well, the transformer is another architecture, and it's all of this crazy stuff going on inside one of these nodes. So I'm not even going to try to explain this. I really don't understand it very well, but I can tell you that when this came out in 2017, it was called the transformer architecture, and that's the T in GPT, by the way, General Predictive Transformer. When they started using these in the neural networks, they started to see really awesome, emergent properties and benefits. So one of the emergent properties of transformer architectures is called long-range dependencies. And so let me give you an example of what this means. In a sentence, although it was raining heavily, John decided to go for a walk. There is a deep meaning, there's a deep connection between the words although and decided. So there's a relationship between although and decided. He decided although it was raining. So we know that semantically that those words are related, but lexically they're separated. So they're very far apart in terms of the sentence. They're not sitting right next to each other. So past architectures would have had trouble understanding that there was an important relationship here, But transformer architectures are very good at recognizing these relationships. And that idea, it manifests in what we call semantic meaning. So a sentence like the jets drove 15 yards versus 15 gunned down by droves of fighter jets. Lexically, those sentences are very similar. They have a lot of the same words, but semantically, they mean very different things. And these models are very good at understanding that meaning. Another side effect, unrelated, is that these transformer architectures, they lend themselves very well to being parallelized in a way that they can be computed on GPUs. So graphics processing cards are better at scaling these transformer architectures out to larger and larger models. And I don't know much about it, but it's really allowed us to build bigger and bigger models than maybe would have been possible on the same hardware in these old architectures. Okay, and very briefly, I just want to point out that with semantic meaning and GPU scalability, another really sort of defining quality of these transformer models is that they're very good at handling multimodal data. So multimodal means different media types, an image with text, like an image with captions, or an audio recording with text. The relationships between those different modalities, these models are great at handling. So like the canonical case would be, you have images and case reports and so forth, all this medical data coming into the system. And then on the other side, you have the patient with text asking questions or taking a picture of my hand and saying, like, what is this rash? And all of those different modalities sort of come together in the model, and it can give you output. This is why these models are good at generating images from text and vice versa. So again, this is just multimodality is a very important sort of defining emergent property from these new architectures. So if you're old enough to remember 2001, the greatest AI of all time, Smarter Child, was released into AIM. And it was like an early ChatGPT, except way better. And then nothing happened for a while. Uh, and the trajectory that we're on, the course that we're on now, sort of started in 2014. 2017, though, was really like the big year, in my opinion. That's when the transformer architecture that I just talked about debuted. And it was discovered by Google researchers. So Google was first in line, and they were at the forefront of this technology. In fact, they released a transformer model, BERT, only a year later. So Google really had these transformers out before anybody else. In 2019, OpenAI released GPT-2, and then in 2020, GPT-3. And if you were not in the AI space, you probably didn't hear about these. These models were good by those standards, but they really weren't like ChatGPT level. So this was all percolating, as early as 2018. Deepfakes kind of blew up in 2020, and that was kind of a wow, watershed moment for a lot of us, but we sort of went on our daily lives. 2021, you had some of the first like good text to image models with Dolly, even though they were like nothing like what you can do today. And then really in 2022 is when it all exploded. So we had Midjourney and we had ChatGPT, and this was like, I think, the first time that the world looked at this and went, wow, something different and important is happening here. To give you an idea of the time scale, ChatGPT was the fastest app to ever reach 1 million users. So it happened in 5 days. By comparison, an app like Twitter took 2 years. And this is really amazing when you consider the amount of, GPU hardware required to run an AI inference server. As someone that works in that field now, it's non-trivial to host a chat app for 20 users. So the fact that they were able to scale to 1 million users in 5 days, it's just very impressive. And I just want to give a shout out to OpenAI's like engineering prowess, even outside of AI, because that's like just a compute problem. So good for you guys. All right, so I think it'll be a fun exercise to sort of draw some parallels on how maybe Gen AI might evolve in three eras, just the way cloud did. And this is all speculation, so take it with a grain of salt. Just like we had the bare metal era for cloud, I think what we're in now, or maybe we're wrapping up now, I'm going to call the bare model era. So with cloud in the bare metal era, you were leasing servers and like raw hardware. I think now we're sort of leasing raw intelligence. So we have these primitives, like instead of EC2 instances as the unit of, compute, we sort of just have these general models, and this is like a unit of intelligence. Just like we had S3 for cloud storage, we now have vector databases. It's like a pairing the wine to the dinner between models and vector DBs. And hosting is in its nascent stages. So cloud providers are beginning to give you managed services for cloud hosting like Bedrock, or there's open source alternatives like Olama or VLLM. And I think this era is characterized that it's lowering the barrier to learn. Um, some of the major players in this era, obviously you have like OpenAI and Hugging Face. Um, when I made the slide Runway, but with Sora coming out in the video space, who even knows? And I think just like Dropbox was the defining app of the bare model era, if Microsoft plays its cards right, then Microsoft Copilot should really be the Dropbox of the modern day. And why I say that is there's really this push across all enterprises. There's like this, the city of gold, this El Dorado to be found with getting all enterprise data into a consumable form that you can interact with through AI. And the company that is the most trusted with that data today is Microsoft. Most organizations use Office 365, they use Microsoft Teams, they use SharePoint, PowerPoint, all these technologies, this suite of technologies are being trusted to host corporate data. And so if Microsoft can insert AI into all of these information streams and sort of build an internal like AI model database for your organization, like that's money right there. And it's almost like as Dropbox was, 10 years ago, get all your files into it. I'm imagining like getting all of your company's information into these AI models in a way that you can securely interact with them. Employees can ask questions about company policies and vacation time and all that. That's really like ripe for the plucking if Microsoft just, sticks the landing. So yeah, I would invest in Microsoft stock if I wasn't broke all the time. I think, thinking forward, just like we had the microservices era, I'm imagining something like the agent services era, where just like cloud services kind of cropped up everywhere. Everything you used to do was a cloud service. Now it's almost like everything you used to do is now an AI service. So like, just to give you an example, I can spin up a database in the cloud, but I still have to know SQL to interact with it. I'm imagining in the near future, maybe I don't even have to know how a database works. Maybe I don't need to learn a structured query language. Maybe there's an AI, layer there where I just kind of define what I want out of the database, and all of that is handled by AI. And I can almost imagine like most modern computing services sort of have an abstraction layer where AI is making the barrier to entry much lower. So I can also imagine this era is going to have lots of on-demand ads. And now with like AI video creeping up, I'm just like imagining a near future where instead of seeing, a generic mattress ad, there might be a mattress ad that's created on the fly for me. So that's going to be fun and scary. And ultimately, like, I think the advertising is going to be the defining uh, app of this era, which sucks. Um, but content creation, it's gonna be pretty wild to see what people are able to build. And I'm just saying, this is gonna lower the barrier to create across the board. And then just like we're in the cloud native era today, in the future, maybe we'll be in the AI native era. where the expectation is that you can interact through like human language with these AI tools in every layer of abstraction. Like for example, today if I want to send an email in Outlook, I kind of have to know a lot of stuff. Like I need to know that Outlook is my email program and I have to learn how Outlook works to use it. I could imagine a future where you can kind of just start with the AI and say, hey, I want to send an email to this person, or I want to get in touch with this person, this colleague. And behind the scenes, the AI is using Outlook, but I don't really have to know how Outlook works. Like I could just say, hey, anytime I get an email from this person, delete it. Well, I don't actually have to know that Outlook is going to set up a forwarding rule or an inbox rule to do that, right? There's also talk about AI like sort of being native in the operating system kernel to some extent. So I'm just imagining like my kids, it's going to be weird to them to open an app or understand like how an application works. I'm also imagining an explosion, a further explosion in creation in this era. So like something like I want to create my own cinematic universe. When I put the slide together, this was pre-Sora. This seemed like, 20 years from now. But now what is it, like 3 or 4 years maybe? Like, I think that's really cool. Think about like your average Joe has a cool idea for an anime. They could sort of start to bring it to life, and I'm hoping in 5 years, like there will be tools to really just purpose build things like your own comic books, your own videos. It's just going to be so wild. So those are my predictions. They probably won't come true. Before we go farther into Gen AI, I think it's time to talk about anxiety, the forever disruptor. So I just showed this slide earlier that I was like, oh, neat. Every time something new with AI came out, my first reaction was like, oh, this is so cool. But that feeling of oh, neat probably lasted 10 seconds and it was followed by hours of oh, shit. So many things about AI scared me. I mean, deep fakes, obviously. Seeing code be written by AI that was really good code. I mean, here's an example from GPT-4 where it's really great at debugging. Like, it's much better at debugging than most people. I constantly copy and paste errors into GPT-4 and it will find them. It saves me so much time. Like, here's one I would challenge you if you can see this. Here's some Python code with a bug, and unless you really understand um, like lambda expressions and closures and things in Python, you're probably not going to see this bug right away. But GPT-4 does. Um, watching it solve physics problems and get them correct. This was me actually just putting a screenshot of a physics problem from the web and watching GPT-4 do it. I mean, I spent years learning physics. Why'd I do that? And seeing it pass these hard exams and do better than the average student, it's pretty crazy. And of course, there's the constant media blitz of hyperbole. And what I want to point out here too is it's crazy because it's like it's not just hey, AI is great and going to take your job. I mean, there on one side of the spectrum you have that. Um, AI is gonna like do your job for you, you're worthless. But then there's also this narrative that is the complete opposite. AI is gonna make you such a good developer that you should be stressed out because you're underperforming. Like this idea that there's gonna be a $1 billion company created by one person, or if you're not a 10x developer, you're doing something wrong. So these are very extreme positions. So it's really no wonder that this stuff is super anxiety provoking. So like I was saying before, when you're caught between extreme positions, these very black and white opinions, there's no wonder it's anxiety producing. So I'm going to go through some of the ones that I hear a lot, and then we're going to like kind of dive into the gray area and try to get to maybe something more approximating the truth. So let me just list a bunch of them out here. Often you have some people saying that something like ChatGPT is just smoke and mirrors. It's just autocomplete, which is insane to still think that. And on the other hand, you have people saying it's just the complete solution to AGI and that problem is done. I hear people say like these AI tools are they're going to be able to do every job on the planet, and you might find that utopic or dystopic. Then you have lots of people, especially on the blog posts that I write, commenting, well, yeah, it can do some jobs, but it can't do my job. And I get this a lot from people that think they're specialists or senior developers, because like they're so special. I had one guy even go as far as to like explain because he does this like at, abstruse audio driver type development. That's very uncommon, so AI can't learn it. But I think it's fair to say that there is, if you learned it, it's learnable. There's information out there to train the AI on. The AI can probably do a better job of learning it than you realize. People are saying this is just the latest buzz. It's just crypto or autonomous vehicles or quantum computing. I think this is different because this came out of nowhere and it's producing. It's like it's producing the fruit. It's exceeding our expectations. I'm still waiting to get in an autonomous vehicle 15 years later. I'm still waiting for a quantum computer to run Doom, but AI just like by leaps and bounds exceeds our expectations of it. Even when we expect what we think is like the ceiling, it just drops something that nobody even saw coming. So I don't think it's just buzz. Some people think that the government's going to regulate it, and so we don't need to have anything to worry about. Or maybe you think that it's just going to become a rogue Skynet and wipe out humanity. Those are very extremely different opinions. I'm hearing a lot of like, well, you really have to learn X, or you shouldn't learn X. Like, you have to learn Python now, or you shouldn't learn coding. These are like very extreme opinions. And we're kind of hearing, this is the best or the worst time to be a Y. And obviously, like, the truth is somewhere in the middle. Okay, so those were all the black and white arguments. I'd kind of like to take a few of them, which are I think the most important ones, and sort of dissect them and kind of flesh out the gray area. So these are my opinions on where I land on these topics, but I think a lot of people probably feel the same way. So in the debate of autocomplete versus AGI, my opinion is I don't care. I don't care if it's actually smart or it's just pretending to be, because it's smart enough to help me in my day-to-day job. It saves me time. It makes me a better developer. I talk to it like it's a colleague. I put questions in it like it's a colleague. I put debug statements into it, and it explains to me what's wrong. Epistemologically, is it intelligent? I don't know. But while people are debating this, OpenAI is going to rake in hundreds of billions of dollars. So I'm going to give you some examples of, as a developer, how I use it, and maybe this will like help you understand why I really believe and feel confident in this statement. So one of the things I asked it the other day, I had to use Terraform, which is an infrastructure as code technology that I hadn't used in a long time, and I asked it, give me a folder structure for a Terraform project that has multiple environments and call them prod and staging. And this is what it came up with. And from what I recall about Terraform, yeah, that looks about right. So there's 20 minutes or 2 hours or whatever saved. Another one, make my Docker files more secure. So lots of people use Docker. Few people use Docker securely. I was one of them for a long time. Now that I'm in government consulting, this kind of became a problem. So some of the things I learned from GPT-4, and granted, this was not a zero shot, so I did go back and forth with it several times, but it taught me things. One of the things it taught me was most Docker containers run as root, and that's dangerous because if your container is hijacked and it has root permissions, it can do more damage than it would otherwise. So just switching to a non-root user can probably like save 99% of security vulnerabilities in a container. Now, actually getting rid of the vulnerabilities, you can use a base image from a company called ChainGuard, which has a public and then a paid catalog of these images for most base images of use, Python, Node, all your typical ones, CUDA that you might want to use. You start with the ChainGuard image, which you could pull off Docker Hub, and it's not going to have any vulnerabilities. And if vulnerabilities come up, they will patch them very fast. Now, when we switched to chain guard, we went from containers that off the shelf in public, in Docker Hub, used by lots of people, thousands of downloads, had 250 vulnerabilities. And these chain guard images have zero, according to like security scans from all the vulnerability databases. Um, so I learned like a lot of important information about security from interacting with GPT-4. So to me, I don't care how intelligent it is because it appears to be very intelligent. All right, moving on. This idea that AI can, am I safe because I'm a senior developer or a specialist? I actually think you're not. I think that AI can replace seniors um, and may be more of a threat to them. This chasm of knowledge between a senior developer and a junior developer, we think it's like this, but to an AI program, maybe it's minuscule. Probably makes no difference. So if I think this is a good time to be a junior developer because junior developers are coming out of school with like a healthy adoption of all these new technologies and tools, willingness to learn. I've met a lot of senior devs who have their head in the sand over the whole AI renaissance. They're cheaper, so if a junior dev equipped with GPT-4 can do 80% of the job of a senior dev, I'd rather hire two junior devs for the same price. And I think overall this reality check is actually good for us um, as a like as an industry. That we are replaceable, that we're not immune from having our jobs taken by technology, like so many other professions have had to deal with over the last 50 years. Um, is AI taking your job or not? Well, I think it's very true that many layoffs are due to AI. You know, Directly copywriting, a company like Stack Overflow, a division like Google Search, these are all directly impacted because less people are using them like the old tools because they're all doing this stuff with AI. Indirectly too, AI is causing industries to shift focus and it's changing like productivity of, people. So indirectly businesses, there's a lot of churn in businesses that's going to result in layoffs. Also, I want to point out that your company doesn't care about you as much as you think. Um, at the end of the day, if they can eliminate a swath of personnel and it's going to save them millions of dollars in their quarterlies, they are going to do it. So just you got to live with that reality. I just want to point out there that many layoffs aren't due to AI. So in the past, we were in eras of cheap money, low interest rates. Companies were overvalued, so they overhired and they overforecasted. Netflix forecasted that we'd all be watching as much Netflix after the pandemic as during the pandemic. And this combination of inflation and high interest, now that's coming to bear, and that's going to lead to cost cutting. And the best way to cut costs is to cut people, unfortunately. People are expensive, especially for companies because they have to pay their salary, extra taxes, benefits. It's very expensive to hire, especially skilled laborers like software developers. Um, and this idea, like when are you going to lose your job? I think like the AI revolution isn't going to happen overnight, but it definitely will happen. The reason it's not going to happen overnight is like enterprises don't trust companies like OpenAI with all of their assets. OpenAI is a software as a service, and so, but like I said before, they do trust Microsoft. Microsoft is entangled in the enterprise stack. It's very foundational now to most businesses, and they already trust them with their assets. You're putting your documents in Word, you're putting your files on OneDrive, and then you are trusting Microsoft with that. And so it's not hard to think that Microsoft is going to, flip a switch and all that is going to go into feeding an AI, and your business is going to have an AI that understands the business end to end. But, government and these laggard industries, like I mentioned before, which I'll bring up the slide, they move slow. So even if it's like possible that the AI revolution can happen in your job, maybe it's not even going to happen for years because of just like regulations and red tape and things. So It's going to happen, but it's not going to move at the same pace. It's going to lag behind the pace of innovation, just like we saw with cloud. Just very quickly, I kind of want to draw some parallels for how tech roles individually might change. So in reduction, I think we're going to see a lot of reduction. And again, I'm speculating, but I think the number of apps that people use, I think like traditional web development roles, search sites, people whose job it is just to be dedicated testers. I could imagine that AI is going to make these jobs less valuable or make people in these roles so much more productive that we need to hire way less of them. Roles that are defined by transformation in the Gen AI era, I'm thinking roles like game engineering, creating video games with NPCs that don't have scripted dialogue, that think on the fly. Um, the way our IDEs are going to be transformed to use AI or CD pipelines, cybersecurity and how it's going to have to battle all this AI generated misinformation, um, cloud services, even like the Internet of Things is going to be affected by these tiny language models instead of large language models. A very interesting field is tiny LMs. Like, how do you get these language models onto a Raspberry Pi, onto a cell phone, onto a calculator? And then ultimately, I think there's going to be lots of growth. So data science, obviously, is just going to keep growing as more and more data is created. Robotics, chip manufacturing, GPU computing, augmented reality. And some of the areas that I think are very interesting is going to be like personalized medicine or agricultural farming. These fields that traditionally you wouldn't think of as like tech fields. I mean, with AI, just imagine the possibilities of an AI bot that knows all of your personal medicine and can like, speak on your behalf. I mean, I can tell you as somebody who's been dealing with parents with cancer and other health issues in the last year, I've constantly valued from putting their medical information into ChatGPT and having it like explain it to me in common terms. So I'm very excited by all this. And what I want to point out, I think this is like if you take one thing away from this talk, it should be this. Notice the transformation and growth opportunities far outweigh reduction. I think because of this, it's scary that we are going to see a lot of traditional roles change or disappear. That is scary. It's going to be hard. Lots of people are going to lose their jobs unfairly. But in 5 to 10 years, when these growth phases kick in or sooner, I mean, there's going to be so much interesting opportunities happening in tech that I think in the net, it's going to be positive. And this is why the title of my talk is it's good to be a software engineer in 2024 because of like just this massive swath of opportunity. So quickly, how do I think the academic landscape is going to be affected, especially in terms of do we need software developers to be trained traditionally? I do think AI is net positive for learning. It's easier to learn now. There's awesome tools like Consensus for searching through academic papers, and you're going to spend less time being stuck on a problem. So you're going to be more productive. But on the other hand, it's easier to cheat or it's easier to excel. So there's going to be a deep stratification between performers. And because of like transactive memory, meaning I know that I could use GPT to solve this problem, therefore I'm not going to solve it like right now or on my own. It becomes really easy to like not go deep on anything. So you can build like a very broad knowledge base, but sometimes being stuck on a problem is good. I mean, that's really when you learn. We've all had a moment where we've been stuck and consumed on a tech problem for so long that we remember it to this day. And being stuck on a problem is like an opportunity. So I do fear that like it's almost going to be too easy to get through academic work, and it's not really going to prepare us for what happens when we can't or use AI to completely solve the problem at hand. Now, I think the question, like, do I still need to learn how to code? I've heard this several times. Obviously some people think you don't, and maybe in the future all coding will be done or 99% will be done with AI. I think that's ambitious. We talked about these laggard industries. There's just going to be areas where we can't fully solve the problem without a monkey in the apparatus. So, where do I stand on this issue? Um, I I think that we should let students use ChatGPT in most cases, and we should challenge them to build harder things than we did. So if you taught a class up until now where you taught some basic Python and it was an intro class, maybe now the final project should be to build like a fully functional website and deploy it in the cloud. I mean, something that a couple of years ago would have been too much work for a freshman. Now that's possible. The kids can do that now. So push them to, use AI just like the rest of us are doing to get work done. But on the other hand, sometimes they shouldn't have access to it. So maybe on tests or certain environments, certain projects, like restricted in a way where they can't use AI. I think like having them struggle here and there is overall a good thing. And like at the end of the day, I was asking somebody like, imagine I have no experience as an architect, but you give me ChatGPT and you task me with building the Brooklyn Bridge. I could probably figure out a lot about building the Brooklyn Bridge using a tool like GPT. Um, but at the end of the day, like you really wouldn't trust the bridge unless a person that had built lots of bridges was the architect on that project. And I think it's the same with code. So in Thailand, this is the word for balance. And I think the key is like, yes, you should learn to code well. Yes, you should use tools like GPT, and you should find a balance that really makes you like, both having both breadth and depth. And that's a tall order. I mean, no one's expecting more from this like junior class of graduating developers than like had come before them. It's just the expectations are insane, but they have tooling unlike anyone before them. I want to talk in general now just about anxiety in tech and how to cope with it. It's important to remember that before all this Gen AI, there was still a high ambient baseline of anxiety in tech that is really underspoken. So this manifests in forms of imposterism, anxiety about the unforgiving job market, or the interview gauntlets where you do 5 interviews just for a company to tell you they're going in another direction and it's not their policy to provide feedback. Rampant burnout. I mean, there's anxiety in tech all to begin with before AI. You're not alone. We all feel it. So what helps me is to keep some perspective. I like to remember that like right now we're at the zenith of this digital age. I mean, trillions of dollars, 70 years of research and technology has all gone into modern computing and AI research, and so many like academic disciplines have converged into this point in time where we have an amazing technology like these Gen AI tools. So when I think about all that, I realize it's not like this just kind of came on the street and took my job. Um, if anything, like I should not be able to even compete with this stuff. So the fact that I still have a place in technology is still kind of amazing, and just kind of keep that perspective. It helps me. I also like to keep the perspective that it's not the year 1349, which was one of the worst years in history. Look it up. There was plague, there was war, there was like religious genocide. There was a volcano that spewed ash over Europe and caused like a terrible famine. When I think about like what life could be like, I guess it makes me remember it's really not so bad. Also, I like to remember that engineering always has a shelf life. 99.9% of all the code that I'll ever write will probably amount to nothing in 10 years, 20 years. Um, Everything you're doing more or less is sort of like rotting away. It's only very few of us that get to build code that lasts the test of time. So in the end, what does it really matter? This is a genuinely unprecedented technology in time, so you are validated in being anxious and kind of being on edge about it. Some things I would really recommend just in general is like unplug, go outside, get away from it. You should really comprehend your worst case. My therapist talks to me a lot about this, like what's the worst, then what's the worst, then what, then what. So my worst case is like I'll just be a janitor and not spend any money, but I think I could be okay with that. I don't mind cleaning. I like listening to audiobooks. So like if you can really come to terms with your worst case, you'll feel better about it. Now's not the time to slack. Like really try to do your best at your job and just, grind it out while for now. Um, Try to not to fall in the back of the pack. Don't be on the chopping block. It's like an unfortunate reality. And I know that's not easy for everybody. People have kids, people have life events. It just kind of sucks. Finally, like lean into your AI anxiety. I mean, that's how I even got here. Like I was feeling so anxious about AI and ChatGPT that I wrote about it, and that led to like the chain of events that ultimately got me a new job, and then that new job allowed me to reconnect with my alma mater, and ultimately that's why I'm giving this talk because I was invited to do the talk by George Washington University. So um, just go through it. If something is really bothering you, I think you need to just like roll up your sleeves and kind of go through if you're not able to go around it. So you can skip this slide. I just kind of want to talk about my personal journey because I think it's instructive. And especially when I gave this talk to GW, I wanted sort of the younger generation to see that success and failure is never like a straight path. So starting in 2011, I was working in a physics lab. I was using Python because I just generally liked it as a language. And I was having these fun debates with nuclear physicists that it is in fact a real language, even though it's not as lead as C++. So I'll get back to that. So after learning Python, it helped me get my PhD. And after getting my PhD, my wife and I, well, it wasn't my wife yet, decided we want to get married. So we moved to Pittsburgh to be around family. Having the PhD and some coding experience, I couldn't get a physics job in Pittsburgh, but I landed a job in fintech, working in a big bank. Because it was a big bank, they have a traditional Java enterprise stack. Eventually, that led me into some work with the identity and access management team. That team was doing lots of microservices, and that kind of got me into the CI/CD, the DevOps kind of pipeline space. And then my wife's family had a medical emergency, so moved to New Jersey, and having that CI/CD experience got me a job working on a platform as a service team, in which case I learned a lot about containers, and this was during that sort of microservices era I talked about, where the container wars were happening. So I got a lot of exposure to containers and container orchestration. And then we moved back to Pittsburgh because we could barely, but technically afford a home there. So when I moved back, the combination of fintech and Python got me a job at a startup doing road analysis, which got me some exposure to machine learning. It was going well. I thought I was on my way, and the pandemic hit, and they had to lean out significantly. So I was unemployed. But because I had Java and this container technology skills, I got picked up by a logistics company who had a cloud application that was running in Kubernetes. So I kind of became knowledgeable about Kubernetes. And eventually, my buddy from 2011 in grad school reached back out to me and said, "Hey, we have my company, we have this C++ application. We're looking to rewrite it in Python." So I said, "All right, let's do it," because Python rules. And that's kind of like the long circuitous path I took. And then having the Python and the Kubernetes experience got me working on vector databases, which are more or less Python programs that you deploy in Kubernetes. And that kind of got me involved in the AI efforts. So that is not a straightforward path to AI, but that is my path. Some parting advice that I wish I could give my 20-year-old self. You're going to have hiccups and hurdles and failures, and your path is going to be non-linear. You need to not lose faith in yourself. For a long time, I thought I was a good software developer. Then I would lose a job, and then I would question, am I really a good software developer? I'd make a stupid mistake. I'd delete some production data. Am I really just a careless idiot? At the end of the day, you have to trust your instincts. And if you like what you're doing, if you're passionate about a technology, you should lean into it. It doesn't really matter what the industry is doing. Just trust your gut and stick with it, and you'll be okay. There's a great book by Cal Newport that completely eviscerates the passion hypothesis, which basically says you should do what you love. Lots of people can't do this. Lots of people don't know what they love. What he points out is that the people that are truly happy are the people that approach their work like craftsmen. If you feel passionate about your craft, when you're writing software, if you're not in a rush to get through it, you want it to be as good as possible. You're almost like a carpenter or something, creating like a perfectly crafted table. That's really like what happiness is. It's as close to it as you're going to get. So lean into that. And if you don't feel that about what you're doing right now, maybe what you're doing right now isn't what you should be doing. Find your core values. Very important thing that I learned way too late. But like for me, my core values are strength and discipline. For some people, it might be family and humor or faith. When you find your core values, it's really helpful when it comes to like making hard decisions. So I would really look into this, and if anyone ever wants to talk to me about it, drop me an email. For you young people out there, there's lots of employment opportunities where you can get your employer to pay for your education. So if you're thinking about further education or getting a certificate or an advanced degree, consider getting in the job market and then getting it, as a side hustle. I really feel strongly that mastering your tools is the most important thing you can do to be an effective developer. So maybe you don't need to learn that eighth JavaScript framework if you still can't work your way around VS Code. Anything I've done with like keyboard shortcuts or just learning my IDE has paid dividends, and I really think this is important. I also think health and ergonomics is incredibly important. So I have a standing desk with a treadmill with an under desk stepper for when I'm sitting. I have a $320 ridiculous keyboard with concave finger wells, which has done so much for the way I feel on a daily basis. And I really think the older you get, invest in these tools. I have an ultra wide monitor. I don't use a laptop ever. It's always closed. I just can't stress this enough that this will pay off in the long run. Finally, spend on yourself. I pay for YouTube Premium. I'm that jagoff. I pay for Medium. I pay for GPT-4. In the long run, though, these things pay for themselves. So don't be afraid to spend on yourself, especially for these little, cheap subscriptions. And so, yeah, I just want to leave you with, if you have the right perspective and you have the right, mindset, then 2024 is a great time to be a software developer. There's going to be tons of growth opportunities. It's going to be scary. We don't really know where the field is going. We don't know what it's going to look like in 5 years. But if you're passionate about it and you trust your instincts, you'll probably be just fine. So lean into it and do what you love and love what you do. Thank you. If you want to reach out, these are ways to contact me. You could also leave troll comments all over the YouTube video if you want. They really don't bother me.